Good morning, everyone. Welcome to PuppetConf Day 2. Hopefully everybody had liberal amounts of caffeine and carbohydrates. I can't tell. All I can see is the ethereal glow of the laptop reflecting off of the delightfully Sissid mini pasty faces out there. I've been, I think this is my 4th or 5th PuppetConf, and every time I come here, it's larger, and I feel smarter whenever it's done. And it sounds a little trite, but I really do believe that in addition to this being a really great conference to talk to people about Puppet itself, I think the PuppetConf is a really great operations conference. Chances are, whatever problems you have, the person sitting 2 seats away from you has probably seen the exact same thing, has solved it in a completely different way, and thinks the way you did it is horrible. So prove them wrong. So there's going to be a lot of great stuff coming up today. There's tons of great speakers. The first person I want to introduce is from EMC. They're doing a lot of awesome stuff integrating with Puppet, as well as their own gear, and they're contributing a lot of great stuff to the ecosystem. And they may or may not be announcing some pretty kick-ass stuff in the next 20 minutes. So without further ado, Dan Hushon from EMC.
Uh-oh. There we go. So thanks everyone very much. I mean, this is like the lifeblood of the IT community that the EMC tries to serve as well as we can. And I thank you guys for all your efforts making IT better, more predictable, more consistent in the face of ever-changing complexity. Today I'm going to talk a little bit about really about complexity and about some of the different layers in IT complexity. Certainly there's massive complexity in the core DevOps capabilities that Puppet is reconciling. But there's emerging complexity layers in the information space and other spaces that I think are really important to think about, using some of the exact same techniques that we've been employing in order to automate IT. So I'm going to lead off with some of kind of EMC's work. So this is core EMC, not the Razor contribution. But we're a pretty big Hadoop shop in EMC. We have a property called Greenplum. We have a distribution. But really interestingly, we are also the testbed for the Apache community. So we've stood up a pretty darn big Hadoop cluster at SuperSwitchNap SuperNap in Las Vegas, with 1,000 hosts that were donated by some of our partners from Supermicros, right? With a full InfiniBand mesh from Mellanox, and Intel providing the processors, and Seagate the disks, and I don't want to do too much endorsement, right? But it was a community coming together to actually serve a community, to provide them a test bed where we could actually push the state of the art with technology, which I think is amazing. But it's a big cluster, right? It's 10,000 potential nodes if we deploy the VMware software into the community, 1,000 if we do it on bare metal, right? 24,000 processors, right? 24 petabytes of disk. It's pretty darn big with respect to its capability to actually move the state of the art. With Hadoop, and I don't know how many of you are actually using Puppet to deploy Hadoop. Awesome. Thank you. Get energized. I know you guys had a late night last night, but get energized, right? We're really using a variety of mechanisms to allow us to both provide one tenant access to the entirety of the cluster, but also the ability to have independent tenants be able to come into the cluster and provision the cluster the way that they actually want to provision it. And so, there are people who are going to sit on top of Hadoop. There are going to be people with Hive and Pig and some of the other tools. There are people who are working on Hadoop Core. And there are people who are looking at new strategies and new distributions. And really the idea is to allow everyone to participate. So the whole cluster, as most things, are pulled together with Zookeeper. But the other really interesting piece are the cluster services, which is how do I keep this thing running? Right? How do I give it its agile and dynamic perspective? And I've circled in purple, just for the Puppet Labs guys, right? The Puppet server, right? Puppet is a critical piece of our core infrastructure in this K2 cluster. And so it really gives the cluster the systemness that we're looking for, as well as the agility. So we're really excited. We're a user internally. Our EMC IT group is also using it internally to work on our cloud, not in production yet, but it's moving in that direction. And I think that one of the things we've been seeing is that the vibrancy in this community is unlike other DevOps communities. And we really appreciate that. And so we're going to continue to contribute as much as we possibly can to this community, both something we'll talk about later around Razor and potentially up on top, because we actually think that actually the DevOps style is very valuable in terms of total system configuration. So I'd like to move into a section where we kind of talk about the extensions of DevOps, right? There's a massive growth of that DevOps platform for IT administration, but there's some other interesting things that we're going to be thinking about, right? So, one of the really big challenges that we have in the industry, and I mentioned Hadoop, is because we're really, EMC is a storage company, right? We're a big software company, but fundamentally what we do is produce and store and manage information. And that information is growing. Right? You look at the weather data at 2.3 petabytes. You look at some of the research programs that Ian Foster, A&L, is tracking, right, around exascale computing. Right? Exascale is about an exabyte of information online, right, for use by scientists. Right? This is a pretty massive amount of information. To the point where, we're really talking, right, about somewhere north of 1 million hosts in order to get there. Right, so we're talking about a lot of power, probably 1/10 of a power station in power, right? These are big clusters that we're participating in. And it's driving into pure science, but what we're also seeing in business, right, whether you're the Googles, the Amazons, the NICEs, the others, right, is that fundamentally information is driving the mobile experience, right? It's driving new insights in failure modes and efficiencies. And so information is really going to dominate the application styles as we move forward. The problem with systems of this scale and of this information is that they really are inherently complex systems. It's not like I have one data set, right, which is this big. Right? It's a culmination of actually reading across hundreds of potential data sets fairly dynamically, allowing people to bring their data to the party. And this makes it hard. Right? And I don't want to get too scientific on this community too early, right? But there is a definition for a complex system, and it actually reflects both the core DevOps values, I believe, as well as this new information landscape. Right? You got a massive number of elements and connections in your environment that you're trying to manage. Right? And not only that, but it's not homogeneous. Right? If it were homogeneous, a lot of the things that we do would be pretty darn easy. You script them, and it's always the same. But when they're different, the challenge begins to emerge. They don't always have clean boundaries, right? As you go through a map of IT, it's not like I have all of these nice little silos of applications which are totally independent of one another. There's an interdependence of the applications which forces us to put systemic change management mechanisms in place, right? They may be open. It's constantly changing, right? Pieces are emerging at the edges, and you're in a constantly changing environment, and so how do you manage that, right? The systems may have memory. There's state living throughout the infrastructure that you have to respect as you make changes in the environment. The nonlinearity of the systems, which means that if I make one change, it can have a ripple stream down effect, right? These are all things that define your world, right? So let's figure out, right, how do we begin to emerge these operational platforms that naturally have the right facilities to manage these kinds of complexities, right? And there are mechanisms to manage complexity. Right? If you look at the characteristics of complex systems, right, there are things that we do. We distill to the minimum point of independence where I can really treat something as an independent component. I then link those components together into hierarchies that actually define a particular behavior. And then I actually design partitioning models that help to maintain the independence even of those hierarchies and manage across the boundaries. And we do this every day. We just don't talk about it that way. But it's important to recognize that there's a whole set of science that actually helps us to lead the Puppet from the small cluster development into, I need to move into the cloud. How do I keep my IT consistent as I move to a cloud provider? Well, is the cloud a hierarchy or is it a partition? How do I decide what I can move and what I can't? Right? These help us to make those decisions and begin to, I think, treat them in a much more consistent way. Let me just give you my perspective. Right? So at EMC, I work for our CTO. And my key role is managing kind of 3 key pieces of the portfolio. So the big data pieces is really my key workload, right? So as we look at designing a system, you really look first at workload. And you say, what's the workload demand of the underlying infrastructure? So the workload is this notion that we're growing exabytes of information that's really coming in through the edge of the internet. Right? There's a very interesting pattern that's happening, which is that it starts to, you really want the data to live very, very close to where it's produced or consumed. And so that really changes the paradigm. As mobility really takes off as the leading information provider, right now I would bet that most enterprises produce about 30% of the information that they operate on inside their four walls. And the rest of that 70% really emerges from the internet and partners that are network connected to the edge of the environment. As that ratio goes down more and more as you move to software as a service and other things, I think that there's this massive opportunity to begin to actually have an orchestration layer which both not just moves into the cloud, but maybe becomes directed by the cloud. Service providers is the next piece, right? Because these guys are the ones who are the cloud providers. And what we're suggesting is that, when we get to about 2015, we really think that enterprise IT moves very, very significantly towards the cloud because the networks aren't increasing in their performance in the ways that data center networking is. So as the information begins to emerge on the internet, I can no longer afford or have the bandwidth to push all that information back into my data center. Right? So there's some very interesting patterns as service providers emerge of how do we actually allow ourselves, right, to orchestrate within a service provider landscape. And I think, again, the DevOps landscape actually gives us a tool where I've got a service provider catalog and I've got my catalog, and I actually merge the two together in order to deploy services in that provider landscape. And the last piece, we are a core infrastructure provider, is this notion of next generation data center. We build data center in these fairly chunky pieces of fairly specialized equipment, right? And the specialized equipment provides a lot of facility, right, for resiliency and availability and flexibility and agility. But by and large, what we're beginning to see is that the emerging applications, especially those in the information space, are beginning to impart a lot of the availability, scalability, clustering, location independence within their frameworks. And as a result, there is a shift going on in the hardware landscape, right? VMware acquired a really interesting company called Nicira. Right? And what does Nicira really do? It really allows you to have an external control plane on top of a network. Right? So I can begin to actually establish an independence of control from the core data path. Right? And that hopefully sounds pretty familiar, right? What we're trying to do is to drive that control out of the data path band, pull it away from the need to be managed by the individual application and into a system that can schedule and resource manage and drive consistency. As a result, we begin to emerge kind of a new stack, right? And this one should look familiar to everyone because I think all of us have probably built some semblance of this, right? Which is the notion that I've got this infrastructure platform with some set of shared services, right? And we talked about the K2 cluster, right? Everything from DHCP to DNS and other requirements, right? But also the core network resources, compute resources, and storage resources. This is the Razor domain tied into Puppet to provide the customization on top, right? There's the emerging virtual platform, right, as you're trying to either use KVM or VMware or other technologies in order to actually orchestrate a new set of work. There needs to be a question about what's the new virtual information platform, right, that begins to emerge. Is it SCSI or is it something bigger than that? Is it key value? Is it, is it record row? Is it blob? And I think that we have some pretty good ideas there we can talk about. And then on top of that, we really have the new application developer landscape, right? And these are the people who are looking for stability in their new application development. J2EE, as much as we all love it, right, is really looking a lot more like a mainframe these days. And as we're looking for the agility in the infrastructure, we're naturally moving to more modern software frameworks and platforms that have the ability to actually describe the complexities of the service interactions to the platform in a unifying way. Again, another version of DevOps where I now use declarative models to talk about how my application actually comes together. And as a result, I think what this really recognizes is that there's a brand new piece, right, on top, which is kind of platform-level DevOps. And platform-level DevOps on top of infrastructure DevOps is very important because if you're running in a multi-tenant environment, you need to build that hierarchy, right, in order to manage complexity, but you also want the systemness of it. You want sometimes to be able to point down and figure out where is this application running, right? Or what is it running next to? Or who is on this box last, right? And as silly as those questions sound, they're actually important from security and availability and other perspectives. So it becomes really interesting if you can begin to actually suggest that there's a common control plane that emerges, which again, follows a hierarchical model so we can drill down into it for insight. Right? So what do these things begin to talk about, right? So as we talk about platform DevOps or information DevOps, right, what are we really talking about, right? So, you know, the service information fabrics, to wire and configure the connections, routes, and paths across the software landscape, right? To give yourself the access to the brand new policy and control frameworks that govern how those connections actually operate. These are things that application developers have to start to worry about. You know, they might have two pieces that are fairly tightly coupled for performance, but they start to hit a data loss scenario or a scalability scenario, so they want to put a message bus in place that gives them queuing, right? That ability to actually dynamically change that substrate and deploy that into an infrastructure is what the largest, you know, application service providers are doing today, and I think that that can become a common vehicle throughout the landscape. You know, the virtual platform, we know, right? It's customize the containers, right? Provision and customize the containers, the volumes, the channels. Right, channels as as the network, and then the core infrastructure, which is how do I get it up and running, which Razor solves a small piece of, but I think that there's a bigger set of activity that we can go on to make sure that we're actually configuring the switches, right? That we're configuring the storage in a unified and controllable way where all that insight is coming up into a common state manager, right? You know, so we have some pretty grand plans. Right? Systemic state management. The advantages in security or performance or metering and billing or drill down or root cause analysis, right, are all critical. If I can get everyone to begin to emit, you know, syslog and consume, you know, configuration scripts in a consistent way, I can actually begin to create systems out of the independent layers and begin to separate the divide that exists between IT and application developers. Right? Despite the fact that we talk about tearing down the wall, right, and trying to do it through layering, there's still always a need for that communication. And the more that we can make that communication, that system analysis that wants to be provided either at the low level of what the application is doing or the high level of what the infrastructure is doing, is going to help both sides actually trust each other a lot more because it's going to be open and overt. Right? Cross-cloud consistency. Right? We need mechanisms that naturally help me to use the same management infrastructure to deploy software within my environment, in my enterprise, as well as in the cloud. And common monitoring, obviously, which is, you know, one of the things we tried really, really hard with Razor to do is to make sure that we were collecting each step in the boot process. And a lot of you use the recipes to actually collect all the configuration data that goes out, so you actually have a current view of the state of the infrastructure, and that's really, really important. Because what it starts to allow you to do is to drive IT analytics, new ways of actually introspecting the information about how your cluster is running so you can do it better, right? Provisioning and deprovisioning, reproducibility and recovery, right? These are obvious. These are why we do DevOps anyways, right? I'm going to move real quickly because I want to make sure I save enough time for a quick demo through some of the information landscape. Because I really think that if information is the critical workload, we need to figure out how to operate that critical workload. There are some properties that begin to emerge that I think also exist in your community, the multi-language. Right? I need the ability to allow people to feel comfortable in the expressiveness of the languages that they select. It's multi-form, which means, you know, I want to be able to use a key value store on the back end, or a relational store on the back end, or an object store on the back end, whatever I need to use in order to deliver my business most efficiently and effectively. But the system needs to actually tolerate that heterogeneity. It needs to be multi-latency. Some things need to move right now, and some things can wait and be scheduled downstream. Right? It needs to be multi-tenant. It needs to be multi-view. You need to be able to take your own tools into the environment and allow them to produce results that are relevant to you. It needs to be multi-location and multi-policy. Policy being the key aspect of tenancy, right? What are the service level agreements that I'm trying to achieve with respect to my information? What are the trust boundaries that I'm trying to achieve, and how am I going to do that? And out of that is a really complex picture which begins to show that we're beginning to peel apart the way that the different information assets within the enterprise are coming together, right? There is naturally a process and control plane, but there's also a control plane that begins to talk about how these things are assembled. And I think that this is a key element of where we can begin to emerge this Puppet community, right? Which is how do I actually orchestrate some of these complex information services, right? How do I actually manage information emerging at the edge of the internet like a Catalina log out of my web server and push it into my Hadoop environment for IT operations? And how do I actually wire that together? Right now, we do that pretty manually, right? And if we can start to pull that together coherently, we can begin to really take control of that information. Compositional operators, right? These things are all obvious to you because this is what Puppet does. This is what the DevOps community has been doing, and I think that it's critical, right? And so now I'm going to move into the demo just to make sure we have time. And we're going to talk about something new that Tom McSweeney and Nick Weaver have been working on with respect to Razor. And Nick, this is off the press from Nick, so it's not ready for prime time. But we have Windows provisioning running in Razor today. So I'm going to show you guys that real quick. So unfortunately, it's a command line. So for those of you on the internet, I apologize. You probably won't be able to see it. This is our initial image catalog. And you can see right here that there is no Windows currently in that catalog. A lot of other things, but no Windows. And so what we'll do is we'll now take a Windows ISO and we'll drop it into the catalog. OK, so if Nick could type faster, right? So here we're adding the Windows ISO into the environment. And again, this is just a slice, and it's exactly consistent with the way the other OSs work. Okay, and we've now added it. What you can see is that what we've done is we've actually peeled away the ISO, which contains multiple independent images. Okay, and we've actually instantiated that index as independent images in the catalog. And so one of the reboot steps around selecting which Windows image you want to go after kind of disappears, and you can now be very specific as to the specific Windows image inside of that ISO that you want to actually deploy. And so now what we're going to do, right, to the Razor contract, okay, is that we're going to establish and bind a new model and policy. Okay, and so what you're seeing here is that we've defined a Windows model. Here is a machine that right now is in a wait state and is waiting. And so now what I'm going to do is bind and apply, okay, this policy to that node. All right, so I'm going to take the policy, I'm going to update it, and I'm going to say enable. So I'm flipping the switch on it. Okay, we'll see now that it's actually occurred. So now you can see the policy's bound. And now in about a second or two, right, what you're going to see is the system just shut itself down, right, under the Razor direction. And when it comes back up, through the Pixie bootstrapping, okay, we're now going to deliver a custom, right, pre-boot environment into the Windows environment. By doing that, what we pick up is the ability for us to actually deliver payloads from Puppet, right, from Razor, in customizations into that Windows environment and have them be persistent with the pre-boot environment. And so now you see the install process going through, right? It's pulling the client frameworks right out of Razor. So we've been able to specify to a very fine grain or to an appropriately fine grained exactly the specific installation components that we want to actually deliver into that environment. And now we'll see if the normal Windows install will complete in a few minutes. And the reboot will occur, and the system will come up and run. And so I'll let it play through. But I think this is pretty exciting, right? Because Windows has been really lacking an installer that's really consistent with what we've been doing in the open communities. And this now gives us the ability, I think, to take down a fairly substantial value proposition in the Puppet community, who already has a pretty strong affinity for Windows and has a lot of and the platform has a lot of Windows integration capabilities. And so here what we actually see is that Windows now come up. It's a little bit compressed, obviously. Okay? And now we can actually go in and see some of the pre-install and post-install customization. So it's already picked up naming structures. It's already picked up network structures. And we've been able to actually drop that in the pre-boot and then the post-boot capability. And now this Windows server actually has the Puppet agent running within it. And so now we're able to apply we hand off from Razor into the Puppet master. And now Puppet can actually control the post-install customization of that Windows environment. And so with that, I think that we've got the opportunity now to go through that operationalization of the virtual infrastructure. We're going to be working on operationalizing the data services, right? I think when you move past that, then you move up to the application landscape who use those information services. And the value that we have is that we want to very quickly create consistent business insights and change that process from being 6 months to build an information application to something that is, days. And not only is it days in your enterprise, but it could also be, then 5 minutes to actually reproduce the same facility in an alternate public cloud environment. And with that, I'd like to create a special thanks to the Puppet Labs group that's been fantastic hosting us and working with us as a community. And I would be hugely remiss not to thank Nick and Tom for their work on Razor with this community. And we really enjoy all the contributions you guys have made, and we look forward to continuing to deliver as much value as we can. So thank you.